Hi everyone. So I'm Dr. Abdullah M. Uh, I'm the UAV team lead at Minds Private Limited. It's a company in Islamabad, and also I'm an assistant professor at one of the universities in Islamabad, Nashd. And my domain is control systems and control engineering, and my PhD is basically on vaguely drones. So that is why my previous lecture and this lecture both are on drones, so because that's my field, and I make different prototypes, and I work in the theoretical and control domain of the hardware world as well. Uh, and that's a brief introduction of what I do. Right. So today we'll be looking into the topic of latest trends in unmanned aerial vehicles. The short form for this is UAVs. Okay, so these will be the contents of the presentation. We'll start with the introduction of what these UAVs are and what are the types that are in there and what is the historical background. And then we'll see the technological advancements so that how the technology advanced with respect to time in terms of these drones, and we'll see what these drones can do. We'll explore some of its features, and then we'll go ahead and see the importance of communication, how drones and the structure cannot exist without a proper robust communication system. And then we go ahead and look into some of the latest trends, that is the AI and artificial intelligence, AI and the machine learning, and how they are being integrated into these drones, and what is the expected outcome and what we have achieved so far. And then we'll see the practical applications that the drones are used for, and in which domains they are used for. And then we'll see the trends and challenges, and then we'll finally conclude the presentation with conclusions and future works. So let's get into it. So I believe my screen is visible for all, right? Okay. Okay, so let's talk about the basic technical term, that is the unmanned aerial vehicles. From the name, you can get the idea that it is unmanned. There is no human pilot involved in driving the systems, and it is an aerial vehicle. So it's a vehicle that drives in air. So UAVs, or more commonly known as drones, are aircraft systems without human pilot on board. So they're controlled remotely or autonomously via onboard computers. So we are actually driving these systems, but we are not on board. There is no pilot on board. So we have some, let me just select a laser pointer. Just a second. Okay, so we have controllers like these to give the commands to these drones, and we are not actually, we are actually driving the drones, but we are not on board. So there is no onboard pilot. So this is the basic meaning of unmanned aerial vehicles, the UAV systems. If we talk about the history of these UAV systems, they started back in 1907 and the start of World War One. Well, we had those big planes with huge wings, and they just took some flights and flew in air, and the stability was not of that was not that good, and we could not perform a lot of maneuvers. We could not just control the angles, and we could not just go, okay, we want to turn at this angle at this speed, and we want to go there at this in this hurricane. So those things were not that much achievable back then, but there were vehicles that flew in air, and that gave a new idea of a new domain, and engineers started working back in near the start of World War One, and improved designs were made. As you can see, there were different names were given to different designs, and all of these were with respect to time improved, and different designs were used, and all of those were had fixed wings. So there were wings like this, and they give the upward lift force to these drones, and more sophisticated and different design achieved different purposes, and different missions could be accomplished. In the early 20s, what happened was in early 2000s, what happened was we shifted back to this, we shifted to a new idea that had the wings with rotation. We shifted to multi-rotor domain. Okay, so in this multi-rotor, what happens is that we had these very small wings that rotated at high speed, and they generated good enough lift force. They generated good enough lift force that drove those drones at a much faster speed with a much higher robustness. Robustness means that the system is maintaining its position in presence of external disturbances, maybe, for example, a strong wind or a strong gust of wind, or maybe even a storm. So higher stability, more robustness, and aggressive maneuverability. So it can go like it can follow a zigzag pattern in high speed. And if we have big airplanes, we do not expect it to take sharp turns and just maybe swirl around a building in like 4 to 5 seconds. But these multi-rotor drones were able to do all of that. So the main benefit of this was very, very small in size. Okay, and it could do more tasks more efficiently and faster in comparison to those big huge planes. But the main disadvantage was that it was small, so it could not carry anything heavier, and it required a lot of energy to do any of the tasks. So these were the best two disadvantages. But overall, this domain was so good that in the past 2 decades, 2 to 3 decades, we have been working on these multi rotors so much. The world has been working on all of this so much that well, it is so sophisticated right now, and so the technology is so advanced, and I believe so developed that we need to look into something extra, because engineers have worked on it so well because of this efforts, because of its great use. Okay, so now nowadays what the engineers are doing is this: they are working on flapping birds, drones with flapping birds. So the advantage of this is that this has no sound. It works like a bird, like the bird flaps its wings and it flies. The disadvantage is that it cannot carry any weight greater than, like, the payload capacity is in grams, you could say. Okay, and it can fly for 5, 10, 15, 20 hand. That's it. 20 minutes, 30 minutes at max. So it is mostly used for surveillance. But the engineering design is so complex, and with respect to time, we see that we started with something really huge, and then with respect to time, we squeezed it down, and for different applications we designed different structures and different designs. Okay, so if we talk about the engineering role in the domain of this UAVs, well, engineering is the backbone of this UAV system. Well, the electrical engineers are required to design the circuitry and to power the system, and power electronics is involved to correctly give the currents and voltages, the power distribution, and everything. The control engineering is required to perform the maneuvers that a drone can perform, and mechanical engineers are required to build its body that can withstand the weight and the environmental conditions, and it should not be of so much weight. And the communication engineers are required for the robust network that must be good enough so that at a huge distance we can still send it commands. Okay, go to over to that mountain, about that, take that turn, go there, do this, do that. We have to send this communication, these signals at all using wireless communication. So various different types of domains come together in establishing a UAV system. Okay, so there are really well, there are various types of UAV systems. There are rotary wings UAVs. There, the lift force that is generated by the arms, they are rotating arms. Okay, so we have these smaller arms. They are rotating continuously, and the rotation of these arms generate an upward lift that lifts the UAV systems into this air. Okay, then we have this fixed wing UAVs, which are nowadays also quite used a lot, and they were initially back in 1900s. These were the first ones that were designed. These are the fixed wings. Okay, so we have wings coming out of the main body. Maybe you can say the backbone of the drone, the this structure. Okay, so we have these wings coming out of air, and these are fixed. So moving forward will generate an upward lift force, and this way this works. Then we have this nowadays we have these hybrid UAV systems. So what we have here is that we have fixed wings as well as these rotating wings as well. Okay, so they have double the capacity. So the benefit of this fixed wing is that they can fly for longer time. The benefit of this rotary wings is that they do not need a runway like fixed wings to take off from a position, and they can perform aggressive maneuvers, they can take sharp turns, they can go quickly from here to there and perform different aggressive kind of motions. In hybrid UAVs, what we do is that we take the advantages of the fixed wing, that is, it can fly for longer, and we take the advantage of this rotary wings as well, that it can fly longer and take sharp turns and perform aggressive maneuvers. So nowadays, we are working on these hybrid systems as well. Okay, now I'll just take one of these drones, that is the rotary wing drone. It has wings. We can consider it in the hybrid UAV system as well. And we'll see the components that it has. The main components that are involved in a typical multi-rotor quadcopter system. Okay, so we have motors, and there are propellers which have small wings attached to it. These propellers are attached to this motor, and this motor rotates, and hence the propeller rotates, that generates an upward lift. Okay, so we have four motors, and this makes it a quadcopter. Quad states that it has four rotating wings, and so it will be a quadcopter. If we had six motors, it would be an hexacopter. If we have eight wings, eight motors, or rotating propellers, we would call it octocopter. So there are various kinds and different configurations. For now, we'll just go ahead and look to this quadcopter multi-rotor system. Okay, so then we have this control receiver. This is a control receiver. So what it does is that, let's say I'm sitting at home right now, and I just want to say, what I want is that I want my drone to go towards left for 20 seconds and go forward for 30 seconds. So what I would do is that I have a remote control in my hand, let's say, assuming that I would give it a forward command, and then I give it a left command. So this command at my hand is going through wireless communication to this drone. So this control receiver is the one that receives the information from the user and sends it to this flight controller, that in accordance with my in accordance to my commands that I sent, this flight controller decides the motion of the quadcopter of the drone, and it moves in that specific direction. So this control receiver is the one that receives the signals from the main hub, that where the user exists. Okay, and then we have this power distribution board. The job of this power distribution board is to distribute the power to all these motors. It takes into account the battery attached to it, and adjusts the voltages and sends it to the individual motors and all of the electronic components that are involved. So it distributes the power all throughout the drone. We have then this camera, FPV camera, the first person view camera. So maybe, of course, all of you must probably already know that the drones are mostly used for surveillance purposes. So we have this first person view camera that takes the VG into account, and we have this flight controller, the main processor, and we transmit it to wherever we want to display it. So uh, since the video data is it's so huge that we need some special processors, and we need good antennas to transmit the video. So we have a dedicated independent first person view FPV transmitter. So the video from this camera is transmitted via this antenna to the user, where the user is sitting. Okay, then we have this electronic speed controllers. These are the motor drivers that are used to change the speed of these motors, because changing the speed changes overall the motions of the quadcopter system of the multi-rotor. So these are some of the main components that are used in a typical quadcopter system, which is a subdomain of a multi-rotor system. Okay, moving on. So if we talk about the technological advancements, well, these multi-rotor systems that well mostly we use nowadays, even in wings we also integrate this multi-rotor system. So we have the hybrid UAVs. We need really high density, high energy density source of power, because these rotating motors require a lot and a lot of current. Maybe like a quadcopter, a normal size, average size quadcopter can consume about like hundreds of amperes at some instances at full payload. Even a hexacopter and octacopter with eight motors can consume up to 400 to 500 amperes at given the full capacity. So this is so much current. This is so much power. So we should have a source that is smaller in size and can be plugged onto the quadcopter, and it's not so heavy, and it has the capability to give all of this huge amount of power. So the engineers worked and the chemists came up with this idea, and they studied that this lithium polymer, the lipo for short form, lithium polymer. This on the left hand side is the lithium, one of the examples of this lipo battery. These are in high energy density batteries, and taking into account all of those trade-offs, the cost, the size, the amount of power they can give, the lipo batteries are the most widely used batteries for drones all around the world. Even though there are other nickel cadmium batteries and other types of batteries, for example, this lithium sulfur as well, there are other types of battery, but lipo batteries are the most widely used because of a lot of trade-offs. Okay, so they can give you huge amounts of power. We cannot use simple adapters or simple lead acid batteries or other batteries that we use for other basic purposes, because they do not have the capacity to give so much power in so little time, and the drones require a lot of power. This is the main disadvantage of a drone as well, of a UAV as well, that we need to take it down after a certain time, for example half hour, 1 hour, maybe 1.5 hours for these multi-rotor systems, maybe 2 hours, because ultimately it will drain out drain all of the energy out of that power source of this battery, and we have to recharge it or plug in a new battery. So since they consume a lot of power, so we cannot say that can work on maybe solar panels or small amounts of drones cannot work on those, because a basic energy source is not good enough for them. So moving on, well, the structure of the drone is matters a lot. Well, we have the engineers. What the engineers do is that they consider the thrust forces, the drag forces, and all of the aerodynamics effects on this, and they simulate it and define the material that will be used, and then they see the result of what pressure can it withhold, and in what conditions, what will be the behavior of this body. If the motor is rotating at this speed, it will generate this amount of newton of force at this instant. It should not break the arm. For example, this is the arm of the quadcopter system. If the rotator is generating so much force, there is a probability that this arm will break. So what we do is that we simulate everything and we design such a structure with with specific dimensions that it can withhold all that weight and can perform all types of maneuvers that we expect it to do. So the structural construction of the drones is an art in itself, and mechanical engineers do a lot of work in designing the physical structure, and then determining which type of material is also another different task to do. We'll come to that as well. Okay, so okay, so then we have the motors that are used in those drones are not common motors. There are some advanced BLDC brushless DC motors, because they rotate at extremely high speed on very small amounts of voltage. For example, they can go up to 20 to 30,000 RPMs as well, and that's a lot. Some sophisticated, really good motors, and then we have to take into account the material that we will use for the body of the drone. What we do is that we put the characteristics of the material. For example, if we are going to use, let's say, a lightweight aluminium metal, or maybe we are going to use carbon fiber, we put down its characteristics and simulate what tension and what pressure can it absorb, and we simulate different scenarios. Can it stand in this stormy weather, in this wind, and if someone puts this much pressure onto it, will it break or will it hold? We simulate all of these scenarios, and then we determine the best material that must be used. So it must be lightweight, because the body of the drone should be lightweight, because the main purpose of this drone would be to carry something rather than to carry itself. So the lighter it is, the greater possibilities that it can carry an external payload. Okay, so carbon fiber is one of the materials that is most widely used all around the world on these drones, because of its lightweight and really good properties of strength. So we take these into account as well. Okay,
Abdullah,
so
is carbon fiber really expensive?
well, it is somewhat expensive, but the trade-off is good enough that mostly if it's a big industry, and it is not that much expensive if you talk about a good government that requires a lot of these drones. So it is a good trade-off in comparison to the other options that are available in the market. Of course, some cost you have to bear.
Quickly, there's a question from Tom. What is the maximum weight in kilograms that a drone can carry or lift?
Okay, so that entirely depends. That entirely depends on the type of drone that you are using and the size. And well, basically, what we do is that if there exists a mission, for example, we have to carry on like uh, 500 kg of 500 kg payload. We cannot use multi-rotor systems. We have to go for fixed wings, and we have to increase the size of the wings. We will calculate, okay, so this wing will generate this amount of newtons of force, and this amount newton of force will carry like 450. We need to increase the further size. We design the drone in accordance with the mission. So there's no fixed weight that we can say. If we increase the weight of the system that needs to be carried, we increase the size of the drone overall. So
Is there
this
a
small
weight
drone,
limit? Is there a weight limit to be considered basically an unmanned vehicle, and beyond that, it might become like a helicopter or a plane?
yes, of course, there should be a weight limit. I believe it is somewhere like 200 to 300 kg at max, the
Oh,
bigger
wow.
drones.
Okay.
So there exists some, but they are not, well, they are for military uses, not for civilian uses.
And then
So
anything above that wouldn't be considered like a drone unmanned vehicle.
yes. Well, you may need to recheck this the limit that I have just told you. Okay, because I also need to recheck it. It's just a big idea of what I studied once at somewhere. So yes, after a certain threshold, we need to rethink the definition of unmanned, because if the size is big enough, we don't need to like drive it remotely. A human pilot inside it can be used. Yeah. Okay, so then if we move ahead and talk about the features that these UAV systems can perform, well, if we put really good cameras, once the system is in air, it's established, all of those control engineers and all those engineers, they all came up and designed such a sophisticated system, it flies perfectly. Okay, now what to do with it now? So we put a really high resolution camera, and we can use it for surveillance. We can use it to look at objects at night. We can use thermal imaging. We can use thermal cameras. Here's on the right side. Here's an image well, showing a car and a human and other objects at night time using a thermal image camera. So other than that, well, there's a lot of sensors. One of the sensors is this LiDAR, light detection and ranging sensors technology. So what it does is that it can be used to 3D map some of the territory or the terrain from where the drone is moving. For example, I design a drone and I put a LiDAR sensor on it, and it moves over a town. So once it moves over a town, it records all those distances, and I can then recreate that map in 3D on my computer and maybe use it in augmented reality or virtual reality or other for other tasks. So what it is that what will it will do is that it will tell me, okay, so this road goes from this endpoint and this and all this. These were the objects here, but it will also give me the exact heights. So I can actually design a map, a virtual map with all those buildings, the trees, the objects, and the 2D objects and the 3D objects, all of that. So that can be used for various purposes in different scenarios. Okay, so then we have this thermal and infrared camera. So infrared gives you a night vision image, and the thermal cameras, just like before I showed you, they can be used at night for really good surveillance. If we talk about the applications, well, once the drone is in air and it flies, and a lot of things can be done using this. For example, what we can do is that we can put some good sensors on it, and it can go around the town and measure the oxygen level, the humidity, the temperature, the dangerous gases, the useful gases. It can get all those details of the environment of that specific town in right no time, because these drones fly really fast. So this quadcopter configuration, some of this can go up to like 100 kilometers per second. So this is extremely fast. These can be really extremely fast. But that's one of the racing drones are of that speed. But normally for going 40-60 kilometers per second, it's not a big deal. So they can quickly surveil an area and give you the details of the environment, which you can use with the authorities can use for different operations, and get to know better the idea of that environment of that town. So here, a typical basic quadcopter system, we have a camera system here that is used for surveillance. We have this LTE transmitter for transmitting some of the data uh, at, at far away distance. So we have these gas sensors. Various gas sensors can be used to detect the carbon dioxide, the maybe the carbon monoxide, the methane gas, the oxygen, the other stuff. We have this GPS system that tells the position of the quadcopter system, so it knows at which coordinates in space time it will in space it has to move. And we have this serial to USB converter, so they are used to program and upload different types of code to for the quadcopter to perform different uh, functions. There is a microcomputer to process all this data, and there is a voltage transformer to distribute the voltage at every component. Microcomputer uses different types of voltage or gas sensor and the camera and all of those. Well, they take different voltage levels, and then we have this motors that are rotating. So these are some of the basic components for in one of these applications. So these drones are used in agriculture as well for monitoring crop health, soil conditions, and managing irrigation systems. For example, if a farmer has, let's say, well, maybe 100 acres of crops, well, it is very difficult for him to, like on daily routine, go and check all the conditions of of this huge area. So what we can do is just send the drone and use some intelligent algorithms, and using the camera, the image processing, the computer vision, what we can do is check the health of the crops, and we can see if the soils need water or if there are any other issues. So since the quadcopter can move at fast speed in various areas, so it can quickly, like in half an hour or maybe 1 to 2 hours, it can quickly give you the overview of what is the health of those crops, so the farmer can take decisions in accordance with that. Okay, so since we are looking at different applications, and we say that it can do this, it can do that, and it can give us back this, and it can give us back that, all this and that. So we need a really good communication network for all of this to occur. So this is a ground control station where the user is sitting, and it is giving the commands for the drone to do this task, to do that task, to do all of this. Okay, so what we do is that we send a radio signal to this UAV system, and it performs the task. Okay, So if we cut off this radio signal, the UAV will not know what to do, and we may never get it back if it's far away, like 10 kilometers away from the user, and we cut off this radio signal. How will I get it back? I have to command it, come back to me, or have to pre-program it that you remember the position that you were initially. If the radio signal cuts off, you come back to this position. We can go ahead and use intelligent programming for various tasks, but we need we need a consistent communication network. That is why we, in alternate, we can use a satellite network. So if my radio signal is blocked due to whatsoever the reason, I can shift back to the satellite system. But the satellite system might be a bit slow, and my commands are a bit sent at with a delayed version. I can use internet, but if there does not exist internet connectivity in a remote area, well, I have to switch between an intelligent communication network. So it is always better to use multiple possibilities for sending the signal to a drone. So because once you are navigating the drone, or the drone is giving something back to you, in both scenarios, you need a good communication network. If the communication network is disrupted, the point of UAV goes away. So,
Abdullah, a question. How much energy does it take to actually communicate by remote?
okay, so well, we cannot define energy with some numeric value at this because different types of drones will require different antennas, and those antennas depend on the terrain, on the where you are operating. If it is line of sight or beyond line of sight, the gains of those antennas will be adjusted. And for longer communication, we do need a lot amount of energy at the transmitting side. On the receiving side, we can use we use small antennas with high frequencies, and the most energy consumption is at the user side, and it depends which type of drone you are using, and what is your terrain, and what is the longest distance that you want. So there is
So they
no
really don't
fixed.
drain the energy in the batteries on the UAV.
No, mostly what we do, since we have to like save the battery for other tasks on the UAV system. So what we do is that we increase the energy at the ground station. So we have a stronger signal that communicates to this uh, far away UAV system. So it
There's a
does
quick
utilize
question
some of the energy, but not that much.
from Kennedy. Is it true that drones can identify a human being by DNA?
By DNA, I believe it is not possible at this stage, because drones are used for they can process the images, they can process the vision. We have installed a camera. We put artificial intelligence or machine learning algorithms, intelligent algorithms can determine, okay, so this is a moving object, it is going like this and that, and it has a face like this, it has features like this. So it's that human being. It can identify up to that certain. But for DNA, you need physical like evidence and perform some biological tasks. So I believe the answer is no, it cannot.
I know that it can recognize the face of somebody.
Yes, it can. Yes, it
Uh,
definitely can.
Anna asked a question: to what phase of flight the lift is equal to the weight and the thrust is equal to the thrust?
Sorry, can you ask the question again?
Here, Anna, can you unmute your microphone to ask the question?
Okay, hello everybody. I have a question for the presenter. And my question is, to what phase of a flight the lift is equal to the weight and the thrust is equal to the opposite force? So you were
Okay.
presenting the force that are affecting the vehicle in the air. So explain us when these forces are equal to each other.
Okay. Yes. So we call this state as the hovering state. Okay. So at this hovering state, the drone can be in air. It is in air, so it has taken off, but it is not moving in the upward direction. It is not going down. It is not going forward or backward. All the forces are balanced. This happens when the upward lift force is equal to the weight of this drone, because the weight of this drone the gravity acting on it, pulling it downwards, and the upward generated force is making this drone go upward. So when these two amounts are equal to each other, it hovers. At hovering means that it is in space time at a still distance. It does not
No.
increase.
I'm not pleased with the answer because I know when these forces are equal to each other. Lift is equal to weight and thrust is equal to drag when the aircraft is in cruise. When we have a landing or
Okay,
a
so you are,
takeoff, these
yeah,
forces are not equal to each other. But when the aircraft is in the cruise phase, then
mhm,
these forces are equal to each other. Thank you.
yes. Okay, so you were talking about the fixed wings. So I gave you an answer of the multi-rotor systems. So in multi-rotor system, there is no cruise. So in fixed wings, we have the cruise system. So yeah, for fixed wings, you are right. So since I was just talking about this quadcopter system, the multi-rotors, so in all these slides, so I gave you an answer for this specific. So thank you for adding that part. So I believe the
It sounds
rest
like
of
the
the,
cruise and the hovering are kind of the same idea.
yes, yeah, but the drag force that she was talking about, they exist in those fixed wings. Well, they do exist in here as well, but hovering part, uh, the fixed wing cannot hover at a still place. We need multi rotors. Okay, so moving on. So we use this radio signals. We use the radio signals because of the greater wavelength, and they can surpass some buildings, some objects like surpass the human body, and so they can be used for higher range of communication. So that is why we sometimes work. Well, we mostly work in the domain of this radio and microwave for communication with these drones. Okay, so nowadays researchers are working on the 5G networks for these drones as well, because 5G networks provide high speed, they have low latency, and they are robust, and then can transfer huge amounts of data. So let's say we have multiple drones, all of these swarming drones with fixed wings and multi-rotors. All of these are connected to each other and performing different types of tasks. We need data to transform from one to another, and to overall uh, do some task that was assigned to them. We can use advanced communication networks such as 5G, maybe 6G as well, in some parts of the world, to establish such a strong and robust network that is not interrupted and that does not have any latency, and that can transfer huge amounts of data in no time. Okay, so if we talk about the satellite communication, it is very well used for ensuring connectivity in remote and inaccessible areas. For example, let's say we have the user at this point at this point, and it is communicating directly with the drone. And once the drone passes over to a mountain, and the direct connection, the line of sight connection with the drone is broken. Now the mountain is so big that the radio waves cannot go through it, and we have disruption in the communication. So we do not want any disruption in the communication for any instant of time while working with a drone. So what we do is that we send the signal to a satellite at a higher location, and it sends back the signal to the drone, and we establish our communication like that. Carry on. Okay, so if we talk about the latest trend, the AI and machine learning are being integrated with the drones a lot. And let's say if I want to drive one of the drones, it is easier for me to just give it the commands and it can do all the tasks. But if I have, let's say, hundreds of drones, while I need hundreds of pilots at ground station, or every human being, well, driving each drone, but then I need all of them to communicate with each other that don't hit your drones with each other. So that's a bit complex to drive all these drones. If you increase the capacity, you need something autonomous and intelligent enough so all of these combined can do a task without interrupting each other's performance. So here AI and machine learning plays a vital role. So for example, we have all these swarms of drones where we use intelligent algorithms, and we tell them, okay, all of you combined have to do this task. And we tell each other their position, and we tell them that don't hit each other. We pre-program all of the scenarios that are possible in the specific mission that they have we expect them to perform, and then we execute them, and the mission goes really well. So how it works is that, for example, we want the multiple drones. Well, there exist 100 drones, and we don't want them to collide with each other, and well, we don't want them to collide with each other. What we do is that we install some distance sensor. For example, this is a very basic and cheap ultrasonic sensor. There are advanced lidar sensors is a good option to detect the distance. So what we do is that we take the readings from various sensors, and we use intelligent AI algorithm, and we say, if you if you detect another drone nearby you, you again maintain this specific amount of distance from it. Okay, so this way all of those drones, they maintain a specific distance no matter what the action they are performing. Okay, so there is an example of how we use AI to analyze large data sets collected by all different kinds of sensors. Well, there exist many sensors. Let's talk about only two sensors for now, this camera and this ultrasonic sensor that measures the distance of the object that is nearby this drone, the quadcopter system. So on this quadcopter system, we have this ultrasonic sensor and we have this camera system. So two systems. In this camera, we take the original image and use the image processing, and we perform this sophisticated task like feature detection and filtering and optical flow, and then we use this corners mean, which is a detail of this programming language, and we perform all these tasks to identify what is well, the drone is basically seeing and processing what it is seeing. Okay, so we program it. If you see this, it means you have to do this. If you see this, if it means you have to do this. All of this program, all of these intelligent decisions are being done in these techniques. So in we also detect the distance that is nearby the objects, and we integrate all the information from all those sensors into a main program, and we upload it onto the processor that's attached to the drone. And the drone then itself is an intelligent UAV system that can perform various types of actions in air without without interrupting another UAV. Okay, so again, machine learning applications, if we talk about them, then a lot of intelligent decisions can be made autonomously without the need of human intervention. For example, my drone was flying and the battery is now quite low, and after like 10 seconds, it will just fall off the sky. So it will decide on its own that it should land at this instant to preserve the body of the drone, because if it falls from a very high altitude, it may damage itself. Autonomously, upon detecting the low battery, it will try to land, and on landing, it will see the sensors will give the information whether the landing area is a plain surface, or maybe it is a dynamic surface, or a complex scene, or different kinds of scene. And based on that, it will decide where it has to go without the intervention of a human being. So on its own, based on the data from the sensors, it can decide the actions it has to perform to overall get the objective that was assigned to it. So if we talk about the practical applications, so well, I just previously told you that they are quite useful in crop monitoring, and well, they can be used for applying pesticides and reducing chemical usage, and environmental impact is quite good because of their usage. If we talk about their use in infrastructure, well, they can be used in places that are hard to reach and maybe hazardous to humans. And drones can detect faults and can provide maintenance in power lines and various different kinds of fields as well. So in disaster management, they can be used for search and rescue operations. Drones provide aerial views to assess damage after natural disasters where humans cannot reach at drones can reach at a faster rate, and well, they can be they can assist human beings in various scenarios. Okay, so if we talk about the future trends, so since we know that we have two basic main issues. One is the power source. The drone consumes a lot of power, yeah, and so it drains the battery, and after a certain time, maybe 1 hour, 2 hour, we have to take it down because the battery is no more. And the second disadvantage is that it cannot carry a huge amounts of payload. So these are the two things that we have to work on as much as we can. So what researchers are doing is that they're combining the battery with a fuel cell for extended flight times. So fuel cell is environment friendly, and it even though it has its own weight which it has to carry, but overall it can make the quadcopter fly a bit longer in comparison to a simple battery. So what we can do is also work on advanced AI algorithms, machine learning. Well, the benefit is that they're faster. They will make the overall UAV system more effective, and it will be more safer. And of course, it will be cost effective. So working in this domain with the UAV, well, you can get a lot of various kinds of good outputs. So if we talk about the challenges, well, there exists overall in airspace systems. You have all those flights and the satellite communication and the GPS and all the signals already and developed structure by the government. So you cannot just go in and interrupt all those signals with your own communication network, and you cannot just fly your drones wherever you want. So you have to check with the government policies, and then we have these privacy concerns. You cannot just fly the drone onto someone's home or someone's private area and do the surveillance. Well, that's illegal as well in most of the countries, well, in almost all. Okay, so these are the two technical challenges that I just talked about, that we need longer battery life and we need to increase the payload capacity.
And
Okay,
there's a
so
question about, do you using solar cells on the drones? Is that a continuing trend?
okay, so like previously when in the battery slide, I told that the drones require huge amounts of power. Again, I should mention that I'm talking about the multi-rotors. Okay, so multi-rotors, if you use solar cells, the area that is available for the solar cells is not that much, and the if you make the body from the solar cell, the generated energy will be so less that it cannot be directly used. So if we talk about fixed wing drones, yes, we can make the body of that drone because more area is available from the solar cells, and we can use them to recharge the battery. And fixed wings comparatively use lower amount of energy in comparison to these multi rotors. Okay, so there they can be beneficial, but in well, if you reduce the size of the drone and you shift to this multi-rotor, you do not have that much area for the solar cell to install, and they generate very low amount of energy.
There's